Alright, this is my critique of Putnam 2016 A3.
This is Strauss Robinson II speaking. So for my video, I will be solving exercise 2.12 from chapter 2. I'm very excited to be solving this problem. And right now, I'm going to start with writing the information I found from this unique statement. So looking at this problem, they told us that y is equal to arctan x, which means that tan y is equal to x. So I'm going to write that down. It even gave us a boundary or a range for like the y values. So x is equal to tan y, and then the boundary is negative pi over 2, comma pi over 2. And then we know that y is equal to arctan x. And what we also know is that f of x is equal to y.
Alright, so you're conflating two different ideas here. One idea, which I believe you're using, is that the graph of a function in a 2D plane is given by the equation y is equal to f of x if it's a function. But this y is not the same y as the y in the parentheses. The parentheses is a clarification as to what arctan of x means. You can't use this information and assume that it equals f of x. Let's continue.
My bad. We also know that f of y is equal to x.
Alright, I'm not sure what's going on here, but you can't switch x and y.
Nice. So with this question, it gave us f of x is equal to f of 1 minus 1 over x equal to arctan x. So what I'm going to do now is I'm just going to rewrite that equation right there. So we're going to be rewriting, okay, f of x is equal to, no, f of x is f of 1, no, f minus 1 over x is equal to arc tan x. So looking at this, I would like to get f of x by itself. So I'm going to subtract this expression right here on both sides. So I will end up having f of x is equal to arctan x minus f of 1 minus 1 over x. Okay, and now I'm just going to make going to simplify this. F of x is equal to arctan x minus arctan 1 minus 1 over x.
Alright, so you have two contradictory formulas here. You said f of x equals arctan x earlier, and now you have f of x equals arctan x minus arctan 1 minus 1 over x. If you plug in the first one into the equation, you'll get arctan x plus arctan 1 minus 1 over x is equal to arctan x, which simplifies to arctan of 1 minus 1 over x is equal to 0 for x not equal to 0. This is clearly not a true equation, so you see this is not a solution for f. And similarly, if you plug in this to the original equation, you'll see it's not actually a solution. But let's just continue and suppose you have gotten a solution.
Okay, so now that we have that, we can switch the x and y values on both sides. So what I can do now is the following. F of y is equal to tan y minus tan parentheses 1 minus 1 over y. Okay, and what I can do now is find the limits of integration, the y values of the limits of integration, since...
Alright, I'm not sure exactly how you swapped arctan to tan. Maybe you were thinking something like y is equal to tan x, so I'm going to plug it in. But if you did that, you would get from arctan x only to y. You wouldn't get all the way to tan y.
We're going to write the integral in terms of y instead of terms of x. So first, we know our lowest boundary of integration for x was 0. So since we know that x is equal to x is equal to tan y, we can just plug in 0 for x. So you have 0 is equal to tan y. And okay, now we would know that y1 is equal to 0. Now let's find the second boundary of integration by plugging in 1 for x, and we will end up solving for our particular y value. So 1 will be equal to tan y, and now we will get y2 is equal to pi over 4. So now we got that. We're going to rewrite this integral in terms of f of y, and that's exactly why we found those two y values to be our limits of integration. So the integral that we will get is the following. The definite integral from 0 to pi over 4 is f of y dy, and that's just going to be the definite integral of 0 pi over 4, tan y minus tan 1, 1 minus 1 over y, dy. Okay, so now we're trying to solve this integral right here. Good thing to know is that we have the indefinite integral of tan y is the following. This indefinite integral is equal to negative ln absolute value cosine y plus c. This is going to help a lot with this integral. So now what I can do is I can make this simpler. This is just going to be this negative ln cosine y plus ln absolute value cosine 1 minus 1 over y.
All right, this is an incorrect application of integrating the composition of functions. Just because the integral of f of x is g of x does not mean the integral of h of f of x is h of g of x. Because if you differentiate, you'll get h prime of g times f, and that h prime of g term is not necessarily going away. If you differentiate this function that you've written down right here, natural logarithm of cosine of 1 minus 1 over y, you'll see its derivative is not actually minus natural logarithm of cosine of y.
Parenthesis, no, absolute, and close bracket, 0 over pi over 4. And what I will do now is just plug in values for the integral. So this will equal negative ln cosine pi over 4, and then you have ln, then absolute value cosine 1 minus 1 divided by pi over 4. Okay, I can make that a better 4. Okay, actually that looks really weird. Okay, so I'll write this. This is going to be 1 minus pi over 4. And this should be minus negative ln of 0.
Just a suggestion, you should use this sort of horizontal fraction bar. You switched from this perfectly good horizontal bar to two vertical looking bars. And really, these are better for writing this down.
Plus, okay, that will be ln absolute 1 minus 1 over 0. So looking at this integral right here, we can tell I made a mistake. So I think when you solve this integral, it's you can't solve it. So I guess the answer will be D and E. I didn't know how to solve this integral, and this is how far I can go.